So the question is, the protocol is IP and the hardware is Ethernet, then the ARP packet size will be. So to answer this question, you must be knowing what is ARP packet look like. Just have a look on the ARP packet. This is the ARP packet. So here you can see that it keeps this information, and this is 4 byte. This is 4 byte. Then the hardware address, that's a MAC address, is a 6 byte. Then IP address 4 byte. Then again MAC address 6 bytes and 4 bytes. So this makes 28. So the ARP packet is of size 28 bytes. The sequence number and the acknowledgement number field in the segment header. So again, to answer this type of question, you must be knowing the format of the TCP packet. So the segment is like this. So this is the segment, and this is actually the part of the segment. The entire segment consists of the header and the data, and the header will be look like this. So there is something called sequence number. Sequence number is representing the first byte number of the data. So this segment carries some data, and every data is actually TCP is a string of bytes. So here, every byte is given one number, and that is represented by using this field. So sequence number is actually used to represent the first byte number of this packet. So this represents the byte number. So the answer here is byte number. Okay, then next question. An acknowledgement field in a segment tells total byte received, total number of byte received. So whenever we do communication using TCP, TCP is a reliable protocol, and it always acknowledge whatever is delivered. So in the received packet, we get an acknowledgement number is there. An acknowledgement number is something that tells what is the next expected byte to receive. So if the acknowledgement number is 70, that means already 69th byte has been received, and the 70th byte has expected to receive. So this tells the next byte expected to receive. Then the next question is, in the user datagram protocol UDP, checksum calculation strategy is very similar to which of the following? So if you look to the IP, we calculate the checksum. Okay, in the ARP actually we don't care for the checksum. In the UDP, the checksum is calculated, which is optional. In the TCP, we also calculate the checksum, which is mandatory. Now here the question says, which which two protocol use the same kind of strategy? So the strategy, by the meaning strategy, let us go to the UDP, that how we calculate the checksum. So in the UDP, we have to use this pseudo header. Now pseudo header part is actually used to calculate the checksum in the UDP. The same thing we are also doing in the TCP also. In the TCP also, to calculate the checksum, we use a pseudo header. Now, why we use pseudo header? Because here the checksum is calculated for the entire data. In the IP case, when we talk about the IP packet, the checksum is only applied to the header part. But here the checksum is actually applied to the entire data. Okay, and this is also optional. Okay, so then moving to the next part. Okay, the next question says, so in the TCP connection, the initial sequence number at the client side is this 3070. The client opens the connection, sends only one segment carrying this amount of data, and closes the connection. What is the value of sync segment? So we must be knowing that in order to maintain the TCP connection, it's a three phase process. In the first phase, they establish the connection. In the second phase, the data is transferred, and the third phase, the connection is closed. So this is the initial sequence number is actually used when the connection is being established, and during this process we used a sync byte. Okay, means in the option part, we have here optional fields are there. In the optional fields, we have this bit is for synchronization, that is actually used for initial connection. So this number is the same as the very first sequence number which has been generated here. So if the initial sequence number is 3070, then sync will be 3070. Means when the sync packet is sent, then the sequence number for this packet will be 3070 only. Okay, then next, TCP receives a segment with destination port number this. TCP checks and cannot find an open port for this destination. That means this port number is corrupted, you can say. The ICMP message is sent back, and we know that whenever the TCP packet is delivered, and if it is not able to be received by the receiver, then it must be acknowledged to the sender. So the ICMP packet has been sent. So here what is happening, because this port number is getting corrupted, so this packet is going to be discarded, and the ICMP packet will be sent from the receiver to the sender. And this is one error. And the ICMP packets can be delivered for two purposes. One is for the error reporting and the query messaging, and we have different types of errors are there. So we have type 3. Now type 3 means the destination is not reachable, and destination cannot be reachable because of many reasons. So if you remember the ICMP packet format, we have a type, mean why this packet has been created and what actually the reason. So here you can see in the type 3 we have many reasons are possible. So the packet cannot be delivered, and one of the reason is port unreachable. So we are looking for what is the type of this packet. So the type is 3. So the answer here is 3. The next question says an ICMP message has arrived with the header with this information in the hexadecimal. Write the type in number of the message. So if you look to this format of this ICMP, so we have 1 byte for the type and then 1 byte for the code and so on. So if you look to the message, this will give you the 1 byte, the 8 bits. Okay, so out of the entire information, we have to only focus on this because we are looking for the type. The type is the very first field. So 0D means 13. So if you look here, this 13 is basically a query message whose type number is 13. Okay, this is a timestamp message. So the answer is 13. So the correct answer is 13, and which is actually a timestamp message. Okay, the next question is, here the packet has been arrived with the header. What is the sequence number? So again, to find a sequence number, the sequence number is actually available if this ICMP is a query message type. So because this is 0D, that means this is value is 13. So this is a timestamp information is carried in this ICMP. So if you look to this timestamp format, so here we have this type is 13, as you can see here, this is 13, and then code is 0. Okay, then checksum, and then we have the sequence number here. So sequence number means you have to look to the this is 1 1 2 bytes, then 2 byte, then this is again 2 bytes. So you have to look to this field, which is the last field out of these 8 bytes. So if you skip 1 2 3 4 5 6 7 8, this is the field that we are looking for. So if you find out the decimal representation of this hexadecimal, that will be the sequence number which is stored here. So if we convert 0302 base 16, we can get the answer as 770. So the sequence number is 770 is the sequence number. Okay, moving to the next question. Now, again, we have a UDP header packet which carries this information, and what is the length of the data. So to answer this, you must be knowing what is the packet format. So if you look here, this is the structure. 8 bytes are here, and this out of 8 bytes, this 2 4 and this the next after the fourth byte number, we have a total length information. So that means this is the total length information. So total length is actually, if you convert it to decimal, it will be 42, and we are looking for finding the length of the data. So total length is actually the header plus data. So you need to minus the header part to get the data part. So header is actually 8 bytes. So we represent, so out of this 42, which is total length, out of total length we minus the header and we get the data. So the answer is 34. The data size is 34 in this UDP packet. Then the next question says a TCP connection is transferring a file of 9999 bytes. The first byte is numbered 10,000. What is the sequence number of the segment if all the data is sent in one segment? So you must be knowing that when we establish a TCP connection, this is your first, the connection is established, acknowledged. So this is your setup phase, and then this is a data transfer phase, and this is a connection release phase, which we call it as a tear down phase. So it says that only one packet to be delivered, and this segment contains the first byte number 10,000. So this packet is delivered, which carries 999 bytes of information. But as a property, we know that the first byte represent the sequence number. So the sequence number of this particular segment is 10,000 because the first byte number is 10,000 as it is mentioned here. So the answer is 10,000. Okay. What does actually it means? It means the packet contains from 10,000 to, because it contains 9999 bytes, so you can simply add here 9998 bytes and you will get the last byte number. If it is asked in the question that what is the last byte number of this packet, then you can find by this calculation. And you can see here the sequence number of the field of the segment defines the number assigned to the first data byte obtained in that segment. So by using this kind of property, we can find out what is the sequence number of this segment.